Hello everyone, welcome back to Analyst Chronicles. So in this video, we will dive into creating a decision tree model using hot disease dataset. So So here is the dataset details. So we're gonna discuss about the dataset in a few minutes. But before moving further, I just wanted to explain what is decision tree and why do we use it. So basically, decision tree is a classification, and also it can be used for classification problems and also for regression problems. So here we are gonna work with a classification problem. So we are gonna predict whether a person is how likely to get a heart disease with the features we have in this data set. So without any further delay, let me jump into the video. So so these are all the necessary libraries to be utilized in the further part of the video. So I'm using Pandas for data manipulation, and also I'm using NumPy for mathematical computations, and I'm importing train test split to just to split my entire data set into training part and testing part, so that once I'll feed the training data set to get the machine trained. Machine will able to learn the trends and patterns by looking at the training data set, and also, and once a machine has been trained, then I'll feed the testing data set so that the machine will ready to predict the results. So that is the purpose of splitting the data into training and testing data sets. And I'm importing decision tree classifier from sklearn.tree because it is a classification problem, and I'm using decision tree classifier. And to evaluate my decision tree classifier, I'm using accuracy score, classification report, and confusion matrix to evaluate my classification problem model, decision tree classifier model. So I'm using Seaborn to visualize the results, and also I'm using Matplotlib to visualize like heat map and all those things. So this is about my data set. So my data set is, today we are working on a classification problem for heart disease data set. So here is a glimpse of our dataset, which includes features like age, sex, and also cholesterol levels, and whether the patient has a heart disease or not. So you can have all the input features along with the target variable. So here you can see already in this data set, the target variable is already defined with the being one and zeros. One is being a patient is already diagnosed, or a patient has a heart disease. Zero is nothing but patient does not have any heart diseases. And if I feed a similar data to the machine, so after training the model, machine has to predict based on the input features. Okay, if I give a person with details like cholesterol levels, and also with this I'm not sure what is the definition of all these input features, but it is related to the medical field. So if I give something related to the CP, cholesterol, FBS, rest, CG, something like that, and machine has to predict whether the patient our person or patient is how likely to get diagnosed with the heart disease. So that is the main task for this model. So this is my data set. Here you can see the top 5 rows, and along with all the input features and the target variable here. So I just wanted to look at how many zeros and how many ones are there in target variable, because it is if it is a multi-class classification problem, I just wanted to look at it. Is it a binary class classification or multi-class classification? So for that reason, I just used df.target, and value counts will give me all the unique categories. So it gave me there are 165 entries for one and 138 entries for zero. So that is, you can see, that means all the input features entered for 165 people, they are having a heart disease, or they are likely to get the heart disease. And zero is nothing but the person with these input features, they are not likely, they do not have any heart disease, or they are not going to get any heart disease, something like that. this data set says. So let me look at the data in detailed, like column wise data, how many entries are there, is there any null values, and what is the data type of each and every column. So here we have 14 columns. You can see age column has 303 entries, and sex column is also has 303, and CP, trust, TBT, something, all are filled with all the values. We do not have any null values. And also good thing in this data set is like we do not have null values, and also all the columns are filled with the numerical data, so we don't have to work further with the I mean like one hot encoding, like converting categorical to numerical problems or numerical variables. So that we can avoid that step here, since all are in integer or float format. That is nothing but a numerical format, and so that is easy for us to process the data. So that is about a deep description about the data set with all 14 data, all 14 columns, 13 input features, and also we have a target variable without any null values, and also all are in numerical values. And also if I wanted to see the correlation between all the columns, like for example how a person's age is impacting the heart disease, whether like a patient is aged with 45 years or older or 50 years old, or they are getting any heart, is there any relation between the heart attack with the age, or with the gender, with the CP, with the trust, TBS, cholesterol, FBS, something like that. So this will give me a correlation between the columns, like target variable and also with the other columns. So if there is any increase in any age or sex, so is there any, I mean like whether patient he's getting heart disease, or is there any relation with the age or gender, something like that, we can able to look at the like the relationship between the features and target variable with the correlation matrix. So but this will give me data like percentage wise, one being 100% and 0.72, something like 72 percentage of the correlation. I don't want to see that. I wanted to visualize in a heat map format. So that is why I just plotted this heat map. So by using SNS, so I'm just giving my data is CORR, since TF dot CORR is my correlation matrix. So I'm giving this just for the purpose of designing purpose. So here you can see the correlation matrix. So which is like, see all the input features, and this is my target variable. And here you can see the relation, the correlation. Target variable is 34% correlated with the THAL, and 39% highly correlated. These are all highly correlated except REST CG. And also we do not have, there is much 3%, 9%, 14%, and to 28%, 23 percentage of correlation with age and sex. And also so we can avoid this thing FBS, since very less correlated, very, I mean only 3% of the correlation, and and this is only 9%. So this is how you can have a better look at the correlation among the input features as well as a target variable. So the correlation matrix will give us a nice idea before performing any feature engineering, because in the feature engineering we need to select the appropriate features which is impacting my output variable, which is not impacting the output variable. So here if you can see clearly, so this doesn't have much effect on my target variable, because only 14 percentage effect, and this has only 3%, this has only 9%, this has 14%. So less likely, I mean if I remove these features also, I mean my model can train well without these features. So whereas if you can see this THAL CA, which has highly correlated, and this is EXANG, which is 44%, and and this is 42 percentage of the correlation. So these are highly correlated. We are not going to remove those features. So that is what we can have a better idea about all the features with the target variable. So that is about correlation. So let's jump into data pre-processing. So data pre-processing, so here we need to look at the any missing values, and also if we have any missing values we need to handle those missing values. For example, with the missing values we are not able to train the model, because with the NaN or with some missing values, machine will not be trained. It has to be filled with some data points relevant to the data point, so that the model will not get affected, or the data distribution, the skewness of the data will not be disturbed with the replaced or filled values. So in that way we need to fill it. So the good thing with this data set, hard disease data set, we do not have any null values. If we have any, we need to work on filling the null values or handling the missing value, something like that. So here when I see df dot is null, I do not find anything. And see, if there are any missing values, we would handle them as follows, something like that. See the column name and fill a, and we need to give the column name, fill with the as per the category. If it is a categorical variable and without impacting the skewness, we need to fill it with the median, mode, mean, something like that, as per the requirement and as per the model we are preparing. So that is how we can process the data. That is comes under pre-processing. So we are done with basic steps, like we had a better look at the data, and also we check the correlation among all the input features as well as a target variable, and also data pre-processing also done. We do not have any null values. Next step is like feature engineering, nothing but the selecting appropriate features. So these are all my features, and I'm assigning except the target variable, remaining all the columns I'm assigning it to features. So I'm reading with the df of features will give me like x is nothing but input features, and y is being a target variable or output variable. So I'm assigning my target to y. So I defined x and y values. So we have selected relevant features for our model. Now let's jump into splitting the data. So splitting the data, why do we need to split? What is the purpose of splitting the data into training and testing? The main agenda here is like, so we need to split the entire data set into training and testing, so that with the training data, machine will be trained and machine will observe the patterns within the data, how input features are affecting the target variable. So if I feed any new input features, how machine likely to predict the new target variable or new output. So these things will gonna happen only with the training. So that is the reason why with a given data set, I'm gonna divide my entire data set into training and testing. So in the training part, machine will train and machine will observe the trends, and machine will look at the dependency on the other columns, how the output variable or target variable is dependent on, or how it is affecting. Is there any change in any feature? How likely the target variable is changing, something like that. Then when we feed, once the model has been trained, so we need to test the model with the x test, so that we can have a better idea after getting the predictions, so how the model is predicting, something like that. So that is the purpose of splitting the data into training and testing. So I just split the data into training x train, x test, y train, y test. So I have imported this train test split, and I'm just feeding my x and y values. So test as I'm giving 20%, because I wanted to test 20% of the data, and I wanted to train the model with 80% of the data set. So random state I'm giving 42. So now let's jump into the model training. So we trained, we are gonna train the model with a decision tree classifier, because this is a classification problem, and I wanted to use decision tree classifier, and random state I'm giving 42. So model is I'm selecting decision tree classifier, and model dot fit will train the model by giving X train and Y train training data set. The 80% of the training data set I'm feeding to the model dot fit, so that the model will train. So once we run this cell, the model is going to train our model is going to train by looking at the patterns inside the within the data set, like input features and how input features are impacting my target variable, something like that. So once we are done with this step, that means the training has been done. So once we are done with the training part, we need to go further with the predictions. So for in order to make predictions, model dot predict keyword will give me the predictions by passing the testing data x test. So I left 20% of the data aside, right, to test the my model. So that is why I feeded the testing data set to predict the predictions. Now I wanted to, we are done with the training the model, and also we are done with the predictions. Now I need to evaluate my model. Like I have imported this accuracy score and also classification report confusion matrix. Confusion matrix is nothing but to just to see type 1, type 2 errors, true positive, true negative, something like that. So we can have a better look at the confusion matrix, classification report, and accuracy score. So I have already imported this all matrices from Scikit-learn. So now I'm calling those functions accuracy score by passing testing and predicting predicted values, and accuracy and classification report also by passing the testing and y prediction, and confusion matrix is also by giving the y test and y prediction. So with this above data set and with the model, we are getting 75% of the accuracy score. And precision is 84% for 1 and 69% for 0. And recall is 86% for 0, 66% for 1. This is F1 score and this is support. And you can see true positive, true negative, false positive, false negative. So we are getting 25 entries for true positive. That means the model is trained well. So that is how you can evaluate the model by looking at the accuracy score by comparing the original values with the predicted values, original values with the predicted values in confusion matrix, in classification report, in accuracy score. So this will give me a nice idea how the model is behaving once we trained. So that is about accuracy score, classification report, and confusion matrix. So let's visualize the results. So this is my confusion matrix. So we got 25, 4, 11, 21, right? So I just wanted to visualize it with using heat map. So this is my predicted, this is my actual. So true positive, true negative, false positive, false negative. So anything is getting under true positive and false negative, that means the machine is predicting correctly without any error. So these are comes under the errors, type 1, type 2 errors. So that is about the confusion matrix. Oh, see, here I just wanted to visualize the tree as well by using PLT dot. This is I just specified the size of the figure 20 centimeters and 10 centimeters, and PLT tree, and I'm giving this model. My model is decision tree model and filled with true. So this will give me the model. So see, now you can have a better idea how the model is trained in within the data set and how the patterns are. See here, something like that. So this is my model's decision tree model. So this is how we can plot a decision tree after once we done with the training and training the model. So I hope this is some interesting data set with some good visualization part. So if you have any further questions, feel free to comment on the video so that I'll be coming with those new ideas or new topics or new ML lectures in coming videos. If you really like this video, please click on the like button. And also if you are really getting something or getting some knowledge out of it, or if you are able to understand the concept in an easy manner, so please do subscribe the channel. So in this video, we are almost done. So we are done. So starting from importing the libraries and loading the data set, and also we had some details about the data set, and we just had a look at the correlation between the features. And we are done with the pre-processing, feature selection, splitting the data, training the model, predicting the making the predictions, and evaluating the model and visualizing the results. So this is about the decision tree classifier for heart disease. So thanks everyone. If you have any further questions, feel free to comment on the video so that we will have a separate video with the Q&A session. Thanks everyone. Bye. See you in another video.